Let's take a look at this example. Let's write down first everything what we're supposed to find. We have to find P6. Okay, but I'm not going to even write over here that we have to find P6 because R6 is completely disconnected from the circuit, right? It's connected only by ground, and resistor connected only by one terminal to the circuit. Okay, it simply means that that particular component is disconnected. So this circuit is disconnected from the circuit. It's like an open circuit over here. See, there is no connection from this point to this one, right? So you are connected only to ground, but it doesn't mean that current flows by this resistor. So if current doesn't flow, there is no power, because power is equal voltage times current. So if the voltage is not connected, there is no voltage. Also, there is no current, so my P6 automatically is equal 0 watts. Okay, so this resistor is disconnected. Also, I want you to look at resistor R3, because the problem is asking you to find, see the R over here, IR3. Okay, IR3 is equal 0 amps. Why? Because this resistor is disconnected from the circuit as well. It's connected only to the positive terminal, but this gap between this terminal and ground, because this line represents the ground, okay, this gap represents like infinite resistance. So when we have infinite resistance, it means we have extremely large resistance, so current is not flowing over here. Okay, this is too large resistance for current to flow. That's why IR3 is equal also 0 amps. Okay, so actually what we're supposed to find? We're supposed to find this current. Okay, this is the current which will go through the resistor R1 and R2. So we have to find IR1, 2. Okay, we're supposed to find this current. We're supposed to find I total, because this is the current which will go through the voltage source. So this is my, let me write this down. This is IR1, 2, and this is my I total. Okay, so this is my I total. I have to find it. I have to find also IR5. Okay, I have to find it. I have to find P total. Okay, and I have to find P4. Okay, so now how are we supposed to approach this problem? Okay, so in order to find this current, I'm supposed to find currents which goes through these resistors. By the way, if you want to, we can redraw this circuit to make it look a little bit simpler. Okay, I believe this is a good idea. So this is my positive terminal, this is my negative terminal, and this is my, let's say, point A, and this is my point B. So in order to redraw it, I'm going to draw simply something like this. I have voltage source. I have voltage source. This is my point A, and this is point B. So this is the line which represents point A and point B. Now we have resistor R1 connected across voltage source. So this is going to be my R1 over here. Okay, I have R2, right? R2, okay, over here. R2. I have also positive terminal connected to what? R5, and also I have R4. So R4 is next one, because the resistor R3 is disconnected. I'm not going to ever include in my new circuit. So let me just draw R4 over here. okay, because R4 is connected to point A and to point B, which is my ground, and I have also R5. Okay, so this is my voltage source, which I call V1. I have R1, I have R2, I have R4, and I have R5. R6 is not included because it's disconnected, and R3 is not included because it's disconnected. Always draw the nodes over here, okay? This is very important to draw the nodes over here. So, what we are going to do right now, we are going to find the current which goes through resistor R1 and resistor R2. As you can see, all of them are in parallel. So the voltage V1, voltage source, is equal to VR1. This is also equal to VR2. This is also equal to VR3, and this, no, sorry, VR4. And this is also equal to VR5. And this is equal 120 volts. Okay, so next we're supposed to find the currents because the resistances are given. So I can write that my I R1 is equal VR1 over R1, which is equal 120 volts over R1, which is equal 1.1 kilo ohm. So 1.1 kilo ohm. Okay, now I'm going to use the calculator, and I have 120 divided by 1.1 exponent 3. This is equal 109.09 milliamps. Okay, this is my IR1. Next, I'm supposed to find IR2. IR2 is equal VR2 over R2, and this is equal 120 volts divided by 5.6 kilo ohms. Okay, so this is equal 120 divided by 5.6 exponent 3 is equal 21.42 milliamps. So this is 21.42 milliamps. Okay, so this is my IR2. Next, I'm supposed to find IR4. Okay, so I have let me write this down over here. IR4 is equal VR4 over R4, which is equal VR4 120 volts divided by R4 120 ohms. Okay, this is equal 1 amp. Okay, this is my IR4. Next, I'm supposed to find IR5. IR5 is equal VR5 over R5, which is equal 120 volts over 910 ohms. So this is equal 120 divided by 910 equals 131.86 milliamps. 131.86 milliamps. Okay, I found all currents, okay, in my resistors. So next, I'm supposed to find the current IR. Okay, IR12. Okay, so this current, okay, which will go into this wire, is going to be sum of these two currents. So I can write that IR12 is equal IR1 plus IR2. IR1 is equal, we calculated over here, right? So this is equal 109.09 milliamps plus IR2 21.42 milliamps. 21.42 milliamps. Okay, so this is equal. You can use the calculator. We have to practice calculator. So we have 109.09 exponent 3 negative plus 21.42 exponent 3 negative. This is equal 1 Torre 1 milliamps. Okay, so this is my current, which will go over here, which will go from these two resistors, or we can say the current which will go through these two resistors, and we're going to come back to the source. Okay, so next we were supposed to find I total. I total is the sum of all currents, okay, which go through the connected resistor. So this current plus this current plus this current and plus this current will give me I total. Okay, so this is KCL. So I have I R1 plus I R2 plus I R4 plus I R5. Okay, so these two currents we add already. Okay, so I'm not going to add them again. So I can say that this is simply 1 Torre.51 milliamps plus IR4, which is equal 1 amp, plus IR5, which is equal 131.86 milliamps. So this is I total, okay, and it's equal, we have 1 Torre.51 exponent 3 negative plus 1 Torre.86 exponent 3 negative is equal 1.26 amps. Okay, so this is my I total, 1.26 ampere. Okay, so next I'm supposed to find the total power. P total is equal I total times voltage source. I total is equal 1.26 amps times V1, which is 120 volts. So this is equal 1.26 times 120. This is equal 151.2. 151.2 watts. Okay, we found total power. Next, the problem is also asking me as well for power at resistor R4. So P4 is equal VR4 to the second power over R4, okay, which is equal 120 volts to the second power over R4, 120 ohms. So this is equal 120 watts. Okay, so we found the currents, we found the powers, so we can say that the problem is solved.